Yeah, this is what my AI looked like at the start. But you're probably wondering how I got here. Okay, so all of this started when I got back from college for the holidays. And to be completely honest, I was having a great time. I was just being a DJ, doing scrolling all day, doing absolutely nothing. And then it hit me. I actually need to get a job. Like every other computer science student, I had one problem. How do I stand out? I need something that's going to make me different. So naturally, I came to the completely logical conclusion that building an AI to play Snake would get me hired at Microsoft. At first glance, Snake seems simple. The snake moves, it chases food, and it grows. That's how we see it as humans. But under the hood, it's viewed very differently. To a computer, this isn't a game, it's just data. As you can see, what we have here is a grid, where every cell has a position. The snake is just a few of those cells grouped together, and the food is just another cell somewhere else on that grid. And because every cell has a coordinate, the entire game can be described using positions. So instead of storing a snake, we just store a list of coordinates that define it. The food is just another coordinate, and everything else is just simply empty space. And once you think about it like that, the problem becomes something very different, because now the snake needs to decide what to do next. At every step, it has a few options. It can either go straight, turn left, or turn right. But to make that decision, it needs to understand its surroundings, so we need a way to describe what the snake can actually see. From its perspective, there are only a few important things. First, it needs to know if there's danger. Is there danger in front of it, to the left of it, or to the right of it? Each direction is either safe or it's not. Then the next question is where the food is relative to the snake, and also what direction the snake is already moving in. In the end, what we do is we take all that information we just gathered and we turn it into a set of values, which is what the snake actually sees. There's no grid, no graphics, it only sees numbers. So now the snake can see, but how does it actually learn what to do? At the start, as you can see, it has no idea what's good or bad, it just moves randomly, in this case in a straight line. So in order for the snake to learn, we need to give it feedback. If it eats food, that's good, meaning we need to give it a positive reward. On the other hand, if it hits a wall, that's bad, meaning that we need to punish it and give it a negative reward. So instead of hard-coding behavior, we let the snake learn from experience. It looks at the current state, it takes an action, and gets a reward. And then it stores that in memory. Over time, what happens is that it starts to remember which choices lead to good outcomes and which ones don't. For each possible move, the snake assigns a score. These scores represent how good the snake thinks that move is. Higher means better, lower means worse. So basically, instead of guessing randomly, it just picks the move with the highest score. But there's a problem. If it always picks the best move, it might never discover better ones. At the start, these scores are basically meaningless, so if it commits too early, it can get stuck doing something that looks good, but actually isn't. So sometimes the snake needs to do something a bit strange. For example, I want you to imagine you're given two boxes. One clearly shows $1,000, while the other one only shows $10. You're guaranteed to get at least the monetary amount shown on the box. Which one would you pick? Most people, logically, would take the $1,000. But what you don't know is that inside that $10 box, there's actually $1 million, right? So this connects back to the snake, because that's exactly the problem the snake faces. If it always picks what looks best, it might miss something much better. So now what we're going to do is we're going to train the model and track how it improves over time by increasing the number of episodes, which basically means the amount of games of Snake the AI plays. So, after 3,000 training episodes, I would say it's learned how to play the game. It's scoring consistently around the low 20s, but in some runs it's managed to go past 60 points. It's not fully mastered the game yet. It's going to need some fine-tuning and some training to be able to consistently hit those higher numbers. Anyways, I want to thank all of you for watching, and hopefully we'll see each other again. Bye-bye.